Okay, guys, welcome to the OWASP Top 10 2025, the insecure data handling room. So let's start without wasting further time. So it's talking about the cryptography failures, injection, and software or data integrity failures. So without wasting valuable time, let's move directly into the first one, which is about the cryptography failure. Have you heard of cryptography failures? It will happen when sensitive data isn't adequately protected due to the lack of encryption, guys. So cryptography, it's all about encryption, right? Faulty implementation or insufficient security measures. This includes storing passwords without hashing, like storing passwords as plain text, things like that. Yeah, using outdated or weak algorithm such as MD5, SHA-1, DES, exposing encryption keys or filing to secure data during transmission. These all falls under the cryptography failures, right? So how you can prevent these cryptography failures? So preventing cryptography failures starts with choosing strong modern algorithm and implementing them properly, right? So sensitive information such as passwords should be hashed using robust slow hashing functions like bcrypt, scrypt, or argon2. When encrypting data, avoid creating your own algorithms. Instead, rely on trusted industry standard libraries, right? So yeah, you have the practical thing. So let's move on to the practical one. So yeah, you also have another description a little bit, like never embed access credentials, that is to a third party service in source code, configuration file, or repositories. Instead, use secure key management systems or environment specifically designed for storing secrets. Okay, so yeah, I'm not wasting time by reading the concepts only. So let's dive into the practical demonstration. So in this practical demonstration, it's about a crypto lab, so which has a weak XOR cipher, and all three encrypted nodes below uses the same weak XOR cipher with a 4-character length. Okay, since XOR encryption is reversible and the text is short, you can brute force it. Enter the correct key once to decrypt all nodes at once. Okay, so we have some credentials. This is the encrypted nodes, and all three nodes are encrypted using the same weak XOR cipher with a short key. So here the encryption is in short key, and we have a meeting reminder, password reset, and confidential. So all these three are encoded or encrypted under the short key, right? XOR cipher, right? So try a key. We have this option. Enter the 4-character key to decrypt all nodes at once. So we have to decrypt these three nodes at once. We have to enter the 4-character key in order to decrypt, right? So the key contains both letters and numbers. So this is the hint that we get. So the key contains letters and numbers. There will be hint, guys. The first 3 characters of the key are key. Underscore is something that we need to find. We only need to find out the 4th character, right? In order to find that, the first 3 characters is key, right? So let's enter keys. So once I enter that, keys didn't produce readable results. Try a different key. So now we have the decrypted with the keys and some kind of flags, right? And yeah, we have another information, the decrypted content of this is password reset token or something, and some other meeting reminder dates, right? So these are base 64, right? So what happens once you decode it? Like this is base 64. What about thinking of decoding that using cyberchef, right? So yeah, let's do that. But unfortunately the results is like this. We can't able to read that properly, so we have to find the key only here. Okay, so other than that, we also have XOR cipher. Why XOR cipher is weak, right? Short keys can brute force quickly. So this is only short keys. We only need to find the last character, right? So only 4 character. Repeating key patterns makes frequency analysis possible. Like no authentication, you can't verify if decryption succeed without context. Homegrown crypto lacks the security guarantee of proven algorithms. So we have some key informations here. The key is exactly 4 characters long. If it contains both letters and numbers, first 3 characters are shown as hint above. One key decrypts all 3 nodes simultaneously. Right, so you only need to find one key. All 3 characters is shown here. It contains letters and numbers. We only get letters. What about trying number, right? Key 0. Let's try to decrypt all. And guys, look at it. So yeah, this seems to be THM comes exactly, right? The TryHackMe's flag, right? So and there are some, still we need to find something. Maybe you can just perform brute forcing, or you can just enter something manually like key 0, key 1, 2, things like that. Guys, we get it. Like it's key one, key found. You have successfully cracked the encryption. All nodes are now decrypted, including the flag in the node 3. Now we get the flag and we get the other keys are decrypted, right? Meeting schedule for tomorrow 3 p.m. and password reset link, things like that, right? So this is about the weak crypto, guys, right? So yeah, you have to do some manual techniques also in order to get that. If that doesn't work, then you can just do brute forcing using tools like burp suit. Okay, so that's it. So now let's move on with the injection part. Like injection, when you heard of injection and if you see a database, you think of SQL injection, right? So there are other types of injections also. Not only SQL injection, we have the command injection, AI prompts, like prompt injection, and we have SSTI, the server side template injection. Okay, so that is something to keep in mind. When somebody hears of injection, they think that SQL injection. So that's the only injection that most people only knows. So there are other injections like command injection, like prompt injection, and server side template injection. So these are something to keep in mind. Okay, so I'm not going to read entire content and wasting your valuable time. Most people doesn't like me to read the entire content and they just skip that part. So yeah, I'm not going to do that. So as of now, you can just read this by yourself. Okay. So yeah, the main important part is these types of injection, not only SQL, but there will be command AI, like AI prompts is prompt injection. Okay. And server side template injection. So how to prevent injection? Yeah, this is something to keep in mind. Like preventing injection starts by ensuring that user input is always treated as untrusted. Whatever user is inputting, if you have a text box to input some data, whatever the user is inputting, you don't need to trust the user input. So that's the first thing. Rather than passing directly, instead take elements of the input for querying. For SQL queries, this means using prepared statements and parameterized queries. Instead of building queries through string concatenation, for OS commands, avoid functions that pass input directly to the system shell, and instead rely on safe API and process that don't invoke the shell at all. Input validation and sanitization plays a crucial role in preventing these types of attacks. So this is something to keep in mind. Input validation and sanitization is what makes these injection kinds of attacks prevention. Okay, so escape dangerous characters, enforce strict data types, and filter before the application even process the input. Okay, so now we have a practical demonstration for that. So yeah, let me close those useless things right now. And now we have the injection showcase, guys. Understand how insecure template rendering can be dangerous. So this is about SSTI playground. So we have to explore the SSTI vulnerability. And you have this lab intentionally renders raw user input using Jinja 2 template using the render template string. Enter snippets below to observe how template expressions execute on the server. We have a demo payload here, right? So for example, this is a functionality, like I'm just entering AAA and click render, and the rendered output is AAA, right? So I'm just entering 7 into 7 and click render output, and the rendered output is 7 into 7, right? But this is vulnerable to SSTI, like server side template injection, as shown here. So we have some nodes and we have some payloads to try, right? So this is a payload. Like how we can verify that this is vulnerable to SSTI, the server side template injection, right? So when we entered 7 into 7 before, it's the outputted 7 into 7. What we entered is what it is outputting, right? But so this is an SSTI payload. That means we have to put some curly braces at the front and at the end. So once you click render, you can see the output calculates the value inside it, right? So 7 into 7 is 49, right? It calculates it. So that means this is vulnerable to SSTI, the server side template injection. Now let's move on to something deep. Like we can also use something like this payload. So in order to get more information. So now it's config.items will list some configuration and some other informations, right? So what we are going to do, right? We have some informations like it's about Jinja 2 and Python, right? So let's search for SSTI Jinja 2 Python payloads or SSTI Python payloads. So we can use some of the SSTI payloads in order to list files or do things like that. So let's search for that Python payloads. So from here, we have a remote code execution, things like that is showing. So let's try this one. This is about ID, right? So ID is what is there entering. So let's see if it works or not. Yes, guys, it worked, bro. Now you can see root. We are root, right? So yeah, it supports Python, right? So yeah, this is working. So when we change this ID into PWD, let's see if it works. When I render the payload, you can see we are in this app directory, right? So instead of that, we can just enter ls in order to list the files. Right, so hi guys, so that's fantastic. We have Docker file, app.file, flag.txt, requirements.txt, static template. So we have to view the flag.txt, right? So we can just cat flag.txt. So this is how you can just find the payloads, guys. So this is about SSTI, guys. So how cool it is, right? So we will be able to get things using AI, right? So that's fantastic. You can just search for a specific thing. As I understand that it's about Jinja to Python. So yeah, I searched it for that particular payload and I'm able to get that. So easy, right? So yeah, let's move on. So we have the last one, which is about the software or data integrity failure. Like software or data integrity failure occur when an application relies on code, updates, or data it assumes are safe. Without verifying authenticity, integrity, or origin, this includes trusting software updates without verification. Like if you get a software update, you're just trusting, your system is trusting without verification, that may cause some software or data integrity failure. Like, so yeah, loading scripts or configuration files from untrusted sources, failing to validate data that impacts application logic, or accepting data such as binary, templates, or JSON files without confirming whether it has been altered. Like how to avoid, you can how you can avoid the software and data integrity failures. Preventing these failures begins with establishing trust boundaries. Like applications should never assume that code, updates, or key pieces of data are legitimate. So if you're building an application, so make sure that application doesn't trust any other input. It should verify properly. Okay, so and automatically trusted. So their integrity must be verified, right? So integrity means it shouldn't be modified, right? So you have to verify that. So this involves using methods such as cryptographic checks like checksums, MD5, SHA-1. There will be checksums, right? So yeah, if you're one of my viewer, then you know what checksum is, what these kinds of things is. So yeah, for update packages and ensuring that only trusted sources can modify critical artifacts. So let's move on to the practical one, guys. So if you don't know checksum, then you will be able to get from guys from the Nessus website. I saw that. Like, let me show you that. When you search for download Nessus, you will be able to see a page like this. Here we have the checksum, right? So this is the hash, right? So once you download this app, you can check if this hash is similar to the hash that you downloaded, so that you can just verify the integrity of this particular file. Nobody in between you and your computer doesn't modify this particular file. So yeah, you can just verify the integrity using this method. For more knowledge about integrity verification, we have a dedicated video about that, guys. You can just search for that on our channel on Cyberark. You will be able to get that, guys. So I think I don't remember. So yeah, let me search for integrity. So yeah, this is this, guys. So yeah, this is a file that you should check on it, so that you will have a better understanding of how we can verify the file integrity things. Okay, so yeah, let's move on to this lab. So here it is. Okay, so this is about the integrity lab, which is insecure deserialization. So accepting untrusted serialized data without verification leads to code execution, right? So this application accepts serialized Python objects, pickle format, right? So and deserializes them without verifying their integrity or authenticity. Attackers can craft malicious pickle payloads to execute arbitrary code and access sensitive files. So we have the option for deserialize object. Enter the base64 encoded pickle data below. The application will deserialize it without any integrity verification. Right, so we have to view the flag. We have to enter a pickle data in which it is base64 encoder. So why this is vulnerable? No integrity verification. So unsafe deserialization, trust boundary violation, no input validation. These are the reasons why this is vulnerable to insecure deserialization. So we have the attack vector in order to attack this, in order to get information. So craft a malicious pickle payload that reads flag.txt when deserialized. The pickle module allows arbitrary code execution via the reduce method. So this is what we need to do. How we can fix that will be shown here, right? So yeah, use of safe serialized format like JSON YAML with safe load, and verify digital signature before deserializing, whitelist allowed object types, use restricted unpicklers or sandboxed environments, never deserialize untrusted data. Okay, so in order to solve that, we have to craft a pickle payload that reads flag.txt when deserialized. The pickle module allows arbitrary code execution via the reduce method, right? So yeah, let's search this and you will get some information somewhere. And we have a Python code, guys, for the same. Let's use this code. It's a Python pickle module code. So yeah, I'm just copying and pasting it here, and I'm just saving this into a file called one.py. Okay, now I'm just going to execute that particular file using the Python 3 1.py. Okay, guys, now when I executed that, I get a generated payload, and this is the payload. So yeah, it's about simulating deserialization. Yeah, what we can do is just encode it using cyberchef. In the cyberchef, we can just use the 2base64 module. You can just paste it here, use the 2base64. Now it is base64 encoded. So now let's try to use that here. So unfortunately, deserialization got error, unpickling stack underflow. After querying a lot, we get this one. So let's try to use this one. And got it, guys. We get a base64 string for our target. Let's copy that. So this is the code that we get after querying a lot. Let's paste this. Yes, that works, but it shows 0. So let's see if we have any other information, like it's about catching flag.txt. If you still can't found it, then you will be able to get it from the solution here, guys. So the solution includes all the details about this, right? So we have an example code also, and the explanations of this particular code will be there in this solution. Like, so it's about importing pickle and base64 and using the class malicious and defining the reduce. So reduce is what the method is. So yeah, it's defining the reduce, and it will return a tuple, and this will execute the open flag.txt and read it. So it will return eval of open flag.txt, and it is also going to generate and encode the payload. Payload is generating using this, and it is also going to convert the payload to base64, right? So and it is going to print the encoded version. So we have to copy the output and paste it into the form. So let's try this one, and we got a payload, and let's try to paste it here, deserialize. Here it is, guys. So we get a flag, right? So yeah, let's also try to decode this to see what's the output, and this is the output looks like. So yeah, it's the encoded version. So yeah, this is how we can get the flag, right? So that's cool, right? So that's pretty much about it, guys. I hope this video is informative for you. Thanks for watching.